Today I'm gonna continue to review about last week's lecture, and now I'm gonna introduce about GIDR, which is an abbreviation of gate-induced drain leakage. It is somewhat same as DIBR, but what is differ from DIBR is that it happens because of the gate. And by the gate, leakage current happen on drain side, so the electrons can go through the n-type, and yes, and this is not good phenomena. And next is source drain series resistance. And to explain briefly about this, if we scaling down the device, the series resistance would be bigger. So yeah, this is bad phenomena as well. And this is for lead job, and here is a four kind of section. First is snapback, and next thing is ambient second breakdown, and third thing is thermal runaway. And we have to stop the lead job phenomena. And on the snapback side, the current is no longer be decreased, and it will be abruptly rise, and we have to control this very well. Next, we have learned about other FETs such as 3.5, which we also call it as HEMT, and MES FET, JFET, multi-gate transistor. And for 3.5 FET, each material has more higher mobility than other, but it's really very expensive, so we don't use in real field. And next is an abbreviation of metal semiconductor FET, and I'm gonna talk this later. And next is JFET, which is an abbreviation of junction FET, and its structure is very simple. We are controlling JFET by controlling its channel. When we give forward bias, it will gonna act as open, and it also acts as enhancement mode. And if we give reverse bias, it will operate as close, and it acts like depletion mode. And next is multi-gate transistor, and I'm gonna deal this later. And for 3.5, which we call also HEMT, has advantage. First is its mobility is very good and very fast, so we usually use to solve the velocity saturation issue. But it also has several disadvantages. Its interface is very bad, and because its dielectric material is very hard to make, and also as you can see in this picture, as you can guess, its structure is very complex, and it takes a lot of time to make this, and its engineering is so complex, so it is not economical, so we don't use this kind of 3.5 engine things. and it is also very toxic, so it is very bad for engineer to do these kind of things. And for next, I'm gonna introduce about JFET. And as I introduced previous, we control this by depletion region. If we give forward bias, the depletion region that is created on the MP junction, and MP junction will be very small, so the current could flow through here, because the channel could create it here. And for reverse, if we give reverse bias on this device, there will be also a PN junction barrier, MP junction here, and as we learned before, if we give reverse bias, the depletion region would be increased, so the depletion would gonna be overlap, so no current could flow through this channel because it is blocked by depletion region. And if the depletion is overlapped, it is same as pinch off, which we in that case the saturation can happen. And for MES FET, its structure is like this, and I'm not gonna deal with this because it is not that very important. And as you can see, as we learned before, this is bulk type and this is FD-SY, but we usually use bulk type because it is very expensive to make SY, and it is complex than the bulk. So we usually use bulk FinFET nowadays. And in previous, it was really hard to make the SY devices because it was really hard to make. But in the lecture, there was a company who invented the technology to make it more easy, the SY, and this is the process about it. And this is multi-gate transistors, and this is planar double gate, and it divided into a 3-gate FinFET and ultra thin body SY, and this is for vertical structure, and this is lateral. But nowadays we usually use 3-gate FinFET in nowadays engineering. And what we have to focus on this section is the reason why we are crossing these two source and drain, and this is because we have to reduce the contact resistance. And as you can guess from this diagram, each bottom control is very hard to control, so some of the effect can occur. It was my last week's lecture review, and thank you for hearing.